And our last sample question here. Io is one of Jupiter's moons. It's known to have 400 active volcanoes. One of the reasons it's so active is because of the gravitational pull of Jupiter on Io. On one particular occasion, the Sun, Io, and Jupiter are lined up in a straight line, so both the Sun and Jupiter were pulling Io in opposite directions. Using the information given on the chart, determine the net force acting on Io at this time. Okay, the arrangement of the three bodies would look something like this. We have the Sun, we have Io, and we have Jupiter. So we're going to have the force of the Sun and the force of Jupiter on Io. So the bodies, the distance, and the mass are all right there. Calculate each force separately and then add them. Okay, so let's do the force from Jupiter and then we will do the force from the Sun. Okay, force of Jupiter. So we're doing this force first, right here. Okay, G mass 1 mass 2 over r squared. Okay, putting in the values. G is 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. Okay, my masses are going to be, here we're talking about the two masses involved are Jupiter and Io. So Jupiter was 1.90 times 10 to the 27 kilograms. And then we also have Io, which from the table above said 8.93 times 10 to the 22 kilograms. Okay, and we're going to divide that by all of that by the distance between Jupiter and Io, which is 4.22 times 10 to the 8 meters. And the formula says that we now square this. Okay, so this is just brute force, seeing that you can use your calculator at this point. Look at my units, kilograms squared, kilograms, kilograms. Those all cancel out. Meters squared, here we have meters that are going to get squared. We're left just with newtons. So this is a tough one. Make sure your calculator can do this, because these are the type of calculations you're going to see on assignments and tests. Okay, when I did this whole thing out, I got 6.35 and some change times 10 to the 22 newtons. Okay, I'm just about to erase this, so make sure you've copied that down or that you press pause. If I can figure out how to erase it. There we go. Okay, and now I'm going to do the force from the Sun. So again, it's G m1 m2 r squared. So 6.67 times 10 to the negative 11 Newton kilograms squared per meter squared. Okay, my first mass is going to be Io, 8.93 times 10 to the 22 kilograms. And then we're also going to times that by the mass of the Sun. Sorry, I just looked at something. 1.99 times 10 to the 30 kilograms. Okay, this all gets divided by r squared. The distance from Io to the Sun was 7.98 times 10 to the 11 meters, all squared. This is going to come out to be newtons. Make sure you pause, try this calculation out, make sure you can get the same answer that I do. I got 1.86 times 10 to the 19. Okay. Now we're going to have to add those forces together. So just like we did in unit, hopefully you guys have more space on your page, just like we did in unit 1, F net is equal to the force of Saturn plus the force of Jupiter. Okay, well, let's say force of Jupiter is positive and force of Saturn is negative. It's in the opposite direction. So we get 6.35 times 10 to the 22 newtons plus negative 1.86 times 10 to the 19 newtons. Okay, once we add those two together using our calculator, we should get 6.35 times 10 to the 22 newtons. So notice that this was almost all just from Fs. That should have been Fj. Sorry, this one was Fj. And this one was Fs. Sorry, I screwed that up. Notice that this value from the sun was negligible because it was so much further away. So force of gravity really depends on how close you are. Okay, you have some problems to try. What I want you to notice is that I do have the answers written right there. So these are checks for yourself to find the answers. Okay, notice they're right here. Just be aware that if they are a little bit off, it could be because we use 9.8 versus 9.81 for the acceleration due to gravity. Okay, so give those questions, they should be in your handout, a try, and self-check along the way. Take a picture and send it to me if something's not working. Good luck.